New advanced GOES-T weather satellite to be launched in March with fixed instrument. The upcoming Geostationary Operational Environmental Satellite, or GOES, is slated to launch along with improvements in the near future in order to avoid instrument problems which were a major hindrance in the last mission. The previous kind of hindrance will most likely not be an issue, as the GOES-T satellite, which is a product of National Oceanic and Atmospheric Administration, or NOAA, looks to go out in outer space better than ever. Launch details. This satellite is set to launch on March 1st at 4:38 p.m. from Cape Canaveral Space Station in Florida, and it will be spending several months in a commissioning period as well. The commissioning period is simply going to be the period where the capabilities of the satellite will be tested and all kinds of functionality of the satellite will be integrated into space as it goes outside our atmosphere. In this commissioning period, the GOES-T will ride into space as it boards a United Launch Alliance Atlas V rocket. Once the satellite is declared operational, post-commission period, it will be renamed as the GOES-18 and it will be able to monitor the western parts of the United States. This is because it will end up replacing the GOES-17, which was sent into space 4 years ago in 2018. The GOES-17 is functional, but the problem is that it is suffering from cooling problems on its Advanced Baseline Imager (ABI) instrument. After the data of the GOES-17 is handed off to the GOES-18, then the 17 will go into orbital storage. This is because as it will finally become dormant, so it would be better operational to hand over the information it has to the 18. Before we proceed, let's look into the previous iterations of the GOES, which was the GOES-17, so that we get to see what is to come with the GOES-18. GOES-17. The GOES-17, as told moments ago, was released in 2018, developed by Lockheed Martin, and was used in providing multispectral imaging for weather forecasts and meteorological and environmental research. The satellite was based on the A2100A platform and it was expected to have a lifetime of 15 years. But with the cooling problem that was described in the last section, the lifetime of the satellite will be cut short. The satellite was also intended to deliver a high-resolution visible and infrared imagery along with lightning observations of more than half of the globe. 12 days after the satellite was launched was when it reached its geostationary orbit. The cooling issue was noticed sometime around in June 2021. Its major objectives were similar to the GOES satellite, where it is designed to improve the weather forecasts, oceans, and environment as it provides faster and more detailed data in terms of lightning, advanced monitoring or solar activities, and space weather. The GOES-17 can collect 3 times more data at 4 times image resolution, and it can also manage to scan the planet 5 times faster than the previous probes. GOES-17 has the same instruments and capabilities as GOES-16, currently serving as GOES-East, and will complement its work by scanning a different area of the world. GOES-17 is GOES-West when it moves to 137.2 degrees west longitude and cover the west coast of the continental US, Hawaii, and much of the Pacific Ocean. These are 2 satellites that are expected to monitor most of the Western Hemisphere and detect natural phenomena and hazards in almost real time. The capabilities of the GOES-17 allows it to fire track and estimate the intensity of its movement, detect low cloud and fog, track cyclone tracks and intensity forecasts, monitor smoke and dust, check air quality for warnings and alerts, transportation safety, and aviation route planning, advanced monitoring of water bodies that end up causing floods and mudslides. These newly advanced satellites can give real-time updates on countries and their weather and atmospheric conditions. But since this technology is developed by the United States, hence they only allow it to authority to view their own weather conditions. The GOES-T. Moving on to the GOES-T itself, its features aren't too different from the GOES-17 either. It can monitor atmospheric changes such as wildfire, lightnings, fog, or storms that take place across the Pacific Ocean, the western part of the United States, Hawaii, and Alaska. Fires have been very active across the western continental US, and so the satellite is in an ideal position out there to get a really close look at those fires, according to Dan Lindsay, who is with the NOAA and is a program scientist of this GOES project. ABI is ideal for detecting the thermal signature or the hotspots from the fires. Sometimes it's even able to detect the fires before they're reported from the public. This is really critical information to get the firefighters so they can take care of the fires before they can come out of control. The ABI can even manage to track smoke from the fires to let weather forecasters know where plumes are going to approach major cities. It can also manage to track volcanic ash or lightning from thunderstorms, which is going to require massive adjustments to aviation flight paths. Furthermore, the Tonga eruption managed to create a huge pressure wave, which is spotted in space by both GOES 16 and GOES 17. With both the satellites partnering up this way, there is very little chance to miss out on an atmospheric change. NOAA would be proud of its efforts in the entire satellite program. The satellite will also act as a watcher for the space weather, such as solar storms, in order to form a part of the NOAA and NASA's large system, which manages to monitor these solar activities in order to protect power grids, satellites, and navigation systems. The observations from these satellites are even more critical now. When the US is experiencing a record number of billion-dollar disasters, Pam Sullivan, director of NOAA's GOES-R series program, said, "Both the GOES-T and 17 are part of the larger GOES-R series in the works, which is officially going to be a 4-satellite program which is intended to keep the entire system operational through the year 2036, which 14 years from now." Before the two of these, there was a GOES 16 satellite which was launched in the year 2016, and it is operational over the eastern United States. The one which completes the set is going to be the GOES-U, which is going to be launched in the year 2024. The GOES-T will also be better in long-term forecasting as it will have better range. The satellite will also work better with the rest of the fleet along with other satellites. There are going to be metrics such as wind, speed, and direction at different levels in the atmosphere that will gather data in order to improve weather models. There is going to be a lightning mapper which will feed into storm forecasts, while the eyes on solar weather will manage to improve solar predictions. When information from other satellites is received and joined with the information of the satellite, things are going to be so much more prominent in the atmospheric forecast department. First launch and imagery. Speaking of the first launch of the satellite, there were discussions amongst officials to get ready for launch and whether or not any delays would come in this process. As for delays, there were no alarming signs and the launch for the satellite would be right on track. One thing that will have to be kept in mind before the launch takes place is social distancing, because we are still in the time of the pandemic. If anyone from the development team catches the virus, then that would bring about delays in the launch. Manufacturing of the GOES 17 was also delayed in 2018 to address the root issue of the ABI malfunction. The team at NOAA hopes not to repeat the same mistake with the GOES-T, which is why they are making sure that everything will be complete in time for the launch of the GOES-T. The first imagery of the GOES-T should be available in May, and these won't be clear pictures to say the least. Since this will be the first light imagery, hence there would be check-out pictures. They won't be sharp, detailed, adjusted images that we get to see. The detailed images will only be seen later on in the mission. By the month of July, the ABI data should start coming to the relay station, and weather forecasts will be having access to the data around. The time for the satellite to be operational will take another good 10 months. We can hope for the satellite to become operational in January 2023. We can only see and hope things turn out well for the GOES-T because of the mediocre experience received from the GOES 17. The GOES-T will look to make amends for it and show no stutters during its expedition. That's all we have in this video. Make sure to subscribe to the channel to make sure that you don't miss out on any new videos from us.